Hi folks! Today we will add another panel to our list. It uses HT16512 as a VFD driver from the brand HOLTEK. Since it is identical to the PT6312, about which a video has already been made, we will focus our attention on simplifying the code, reducing the number of the lines, thus facilitating the use as a clock in general. It will also focus on a small detail that makes it difficult to bring the panel to life and that can go unnoticed. The connections are the same as always: filament 1, filament 2, GND, less 24 volts DC, data in, clock, strobe, and the plus 5 volts DC. Don't forget the reference of the less 24 volts DC to the power of the filament. You can use a resistor, for example, of 100 ohms between the both powers to make the reference. I will go do the reset to the Arduino to running the test of the numbers. And I like you pay attention to this segment here. You can see the first digit missing the below segment below of the number, okay? Corresponding to the segment D. This happened because the order of the attribution of the segments is not the same between the both digits, okay? As I refer, I reduced the number of the lines in the code to make it more easy to use. This code already has been used a lot of times when we are in face of this kind of the format of the VFDs. I don't change anything in the buttons. The code is present original, and you can press some buttons, for example, for increment the hours, for increment the minutes, decrement minutes, and I think this is a reset. The remaining buttons you can adapt looking to the order number or the bit number present in the output of the IDE of Arduino and adapt to your modifications. This LED here and this both LEDs are controlled by the outputs of the VFD driver. It have the possibility to control 4 LEDs. The panel has a set of 3 resistors in the data and in the strobe pin for a pull-up. 2 resistors of 1K connect to the VCC through a resistor of the 100 ohms. As I normally implement on the communication pins a serial resistor in the breadboard to protect the Arduino ports against possible connection errors, if we apply the voltage divider formula, we will be left with 2.5 volts, which does not change the stats for Arduino. It remains with the height value logic. Given this fact, I had to use 100 ohms in the serial resistor, but this is not good for the Arduino ports. I changed the 2 pull-ups on the panel to the value of 4.7 kilo ohms, but they could be even higher. For example, 10 kilo ohms will be okay, like is the resistor present in the clock circuit.